Welcome. Did you all have a good lunch? All right. Everybody ate the turkey, get some tryptophan. We're going to let the lights down low. Get a nice little nap right now, right? I hope not. My name's John Papa, and I'm here to talk to you today about a really long title. Basically, how do you build Node and JavaScript apps with VS Code on Azure? So we're going to talk about there's lots of ways to do this, but we'll talk about how Visual Studio Code makes this experience so much better than if we didn't have such a great editor to do this. My personal background, I do a lot with Node and JavaScript. I built small apps. I built massive, large-scale apps. I'm going to show you some things that you can do with these apps. I'll show you some live ones, too, as we go through. But through this cycle, we're going to learn how we can deal with things like, OK, we've got an Express server. How do we handle that? Maybe we want to deploy it to Azure. What are our options? There are no less than 10 options how to deploy to Azure. So what is great about having a lot of options? It's great that you have them, but generally you just want to know what's the right one or the recommended one for you. So I'll talk about some of those as well. We'll look at things like how we deploy our websites and why we might want to make the decision to deploy them differently in certain cases as opposed to others. And we'll also look at Cosmos DB and our database extensions and built into VS Code, and how we can use the features in VS Code to manage our databases. So let's start off thinking about our apps, though. When you have a Node app, a lot of times you have more than just Node. You've got JavaScript, Angular, React, Vue, something else on top of it. So your code, we're going to talk about the code in our applications. Angular, React, and Vue are the three biggest frameworks out these days, and they're all awesome. They all pretty much have parity in all the features and technical abilities. And depending on who you ask, it's really just preference. Which one do you like to do? It's like Java, C#, etc. Great thing is Node works with all these. We're going to learn how to debug locally here today, too, using Node on the back end. We're going to learn how to connect to a Mongo database server locally or in the cloud on Azure. And we'll look at how we can push our files up to Azure in a variety of different ways to deploy our websites. We'll explore how Docker works. How many people here use Docker? Oh, that's a good amount. Awesome. How many people here were scared or are currently scared of using Docker? OK. I admit it. When I first got into it, it was a little bit like, why do I need this thing? There's all this extra stuff here. We're going to explore kind of how that journey might look for some of you. And maybe you've already gone through it, or maybe you're going through it now. We'll also look at what kind of things we want to think about when we're deploying an app to the cloud. What kind of concerns that we already had can be solved, and what new concerns might we have now that we're taking our app and pushing it to the cloud. And then we'll look at how all the different tooling that's built into VS Code works. I'll show this slide again, but I wanted to throw it up now as well. Here is a link to all of the resources you'll see inside of the presentation today. If you click on those links, you can get VS Code. There's a free Azure trial. Node extensions I'm going to show are up there. Angular extensions, we're going to look at some of those that help us out with some of the things beyond Angular, like Node and Docker. The extension marketplace, there's only something like 5,000 or 6,000 extensions that you can go grab. So get it from there. And then if you're like me, you like to keep your fingers on the keyboard, you can learn all the keyboard shortcuts for VS Code by clicking on one of those two links at the bottom. But our story starts with great tooling. We're deploying applications. The better the tooling, the more efficient and effective a programmer or developer that we can be. It's really important. I know it sounds like common sense, but when you start writing code, you do a lot of things, I'll bet if you're like me, that are very monotonous. You repeat the same thing over and over again. As an Angular and Vue programmer with Node, what I do a lot is I write my code, I build the project, I look at it in the browser, I go make changes in the code, I build the code, I look at it in the browser, I make more changes, and I do this cycle all day long, hundreds of times. So having tooling that removes all the process and friction of creating all that makes life easy. So first, we're going to talk about, before we go to the cloud, it's important to understand what you need to do before you prepare. If you're ever going on vacation, do you just hop in the car and get on the airplane? Or do you pack? Do you think about what you're going to pack? Some people plan out a week before and lay it out in a suitcase, right? Other people do it like 5 minutes before they get on the flight. But either way, you plan what you're going to do. Before you go to the cloud, your experience on the cloud can be highly dictated based upon how much you prepared that application for it. For example, if you take a raw Vue or Angular or React app and you do no production build of it, if you just take the raw files and you've got a massive project and you throw it all up in the cloud, it might take a long time to deploy. It might be really slow. It might not be a great experience. That's very likely to happen. And if you put it up on Azure, you might then say, well, it's Azure's fault. Well, no. It's slow because all that stuff was thrown up there. So you have to think about how we can optimize our applications, and then how we can build those applications to make them tighter and faster and more efficient. And then finally, how we can deploy our applications. There we go, to the cloud. So we're going to use Angular as an example just for time's sake. We could do this with React or with Vue as well. And kind of what we have to think about. There's tools in all these front-end frameworks called CLIs, command line interfaces. And they let us scaffold out new applications. So a very popular one here is the Angular CLI. It lets you scaffold a new app by saying ng new create my app. And with that, you can tell I want routing in my application, I want to use Sass or less, I can just view the files that are in that application, all sorts of different settings that you can do. But how often do you build a new project? Not that often. You start a project, working for a couple months or a year, and you build a new one. So the CLI's great power is not just in creating it, it's in the things that happen when we want to go to the cloud. It's just the beginning of the story. So after we do that, I've got some bad batteries here. There we go. Either that or I'm not strong enough to press the button. After we get our application ready, I like to think about going to the cloud. There's two different personas. There's what I want to do when I'm a developer, and what I want to do for the user. The developer persona is somebody who's like me, like you, who wants to build your application over and over and over and over again, fast as possible so you can see the results locally. That means you're willing to give up a lot of the production efficiencies and speed that you might get of the end result just so you can see it and get that instant feedback so you can make changes. We use things like ng-build with the Angular CLI to do this. When we go to production, we might use a flag like -- prod. That is for the persona of our end users. Our end users don't care that you rebuild all day long 1,000 times or 100 times. They want to know that the thing that you built and put on the website is fast. Build it, take as long as you need to build it, make it awesome. When I go to the website, if it takes me more than a second and a half, I get bored and I go somewhere else. That's a lot of user experience. So these different personas are important. One of the things that we can do is we can use these prod flags with Vue, Angular, and React CLIs to optimize what's happening. So let's take a look at some of the different options that they have. With this, you can have different environment settings for production or development. You can do cache busting. Production build, you want cache busting because you want to build all the files, and if you make a change to your production site, you want the file names to be different, so it busts the cache, so all the people in the world who are looking at it get the new code. Or if you don't use cache busting in production, your other option is you go tell every user in the world of your application to please go to their browser settings, empty their cache, and reload. Yeah, try that with like a public website, right? Imagine you're on Amazon or Walmart or Target or any major website out there. That wouldn't work so good. So cache busting is super important to keep things moving. We also want source maps, but not in production. We want those in development builds so we can debug our code. So we generate those. Uglification. I love the words in JavaScript, by the way. Uglification. You want to make your code ugly for production. That shrinks down the size, renames your variables. So you can name your variables really long names like supercalifragilisticexpialidocious, if you like. Uglification will rename it to X. Why? Because the browser doesn't care when it's compiled. So uglification is great for production, reduces the size. Bundling. We want to bundle our files so we don't have 10,000 of them going to the browser because that takes a long time, even if they're all small. So we bundle them into small chunks. Code splitting. Sometimes we have a very large app, and maybe the users always go to the home page or the dashboard or the search, but they don't always go into other areas of the application. Thinking about the business rules in your application, this is not a technology problem. It's a business problem. Think about your application and how the business works, how the users consume that application and use it, and then split that code using different features of React, Angular, and Vue into different bundles, so only the bundle they need goes to the browser. This can significantly reduce the amount of time users wait for websites, and then get the other bundles as they need them. It's called code splitting. AOT, this is something that some of the new frameworks are looking at called ahead-of-time compilation. What this does is it basically compiles your JavaScript on the server and sends it to the browser so that the browser doesn't have to do the compilation for every user it hits it. Again, it significantly speeds up the user experience. And one of my favorite ones is tree shaking. Tree shaking is the idea of dead code removal in JavaScript. Have you ever written code, later on you deleted it, or you thought you deleted it, and then you shipped, and that code's not being used, but maybe you never found it? What tree shaking does with JavaScript is when you go production, it takes all the code that's not being used and it shakes it out, drops to the ground effectively, and you only ship the code that you're actually using. When you combine all these things together, you get a much better application that you can deliver for a user experience. The good news is if you're using Angular or Vue or React, they have CLIs that do this for you. All you do is call their build command with a production flag, and it does all this work for you. So before we send our code to Azure with Node, with any backend, we want to make sure that we optimize that front-end logic. That way, when we're running massive apps, large enterprise apps, or even small ones, that they work on devices like this at a conference with 6,000 people, all hitting the same Wi-Fi, and it's still fast. So once you do that, there's other tools you can use. I'm going to provide links to these. You can actually explore your bundles, the code that it generates, using tools like Source Map Explorer or Webpack Analyzer. These two tools will look inside of the bundles that you ship, and it will give you a heat map of the code to show you how big everything inside your code is and everything you're using. I've used this often for production apps, and I've discovered that sometimes I'm including code in libraries I didn't even know I was using, which was then great for me because I can go back to my code and say, you know what, let's find where I'm using that and get rid of it because I'm no longer doing it. Great example is there was a site I helped work on with some folks who worked at Microsoft, and they were using a chart at one point. And they were thinking of putting it somewhere in a Microsoft site. It's all chart data. And they decided not to go there and do that this sprint. But yet the code was still there. The reason we discovered the code was still there is we used one of these tools, and I found, okay, I think the battery finally died. Let's see if I can hit buttons over here. And I found, I was using this heat map over here. Do you have extra batteries? Okay, thanks. Looking at these heat maps here, I found that there was some kind of a chart that showed up. And the larger the rectangle, effectively, the larger the file. And it was just this really large third-party charting tool, which it's fine if you're using it, right? But if you're not even using the chart, why bundle it with your application? So using tools like the Webpack Bundle Analyzer or Source Map Explorer, you can actually identify visually what code you're using in your application. Now it works. OK, so now at this point, we're ready to take our applications to the cloud. We've done the work up front, all of our homework to make sure we can get there. Let's think about what this means to get to the cloud. In a Node application, we need to install our dependencies, npm. When you run npm install locally, what do you usually do? Anybody? Get coffee. Exactly. Thank you. If you don't drink coffee, what do? You read a book. So when you run npm install locally, you've got to get all your packages and wait for this stuff, because maybe you got a slow Wi-Fi, or maybe just using a lot of stuff. But we have to make sure that happens, though. If we go to Azure, it's on a different computer. Unless you're using Scott Hanselman's sticker, if it works on my machine, you've got to make sure it works there too, right? Then we have to build our assets. Make sure we do like our Angular or React build. Maybe we build an Express server up with Node with our dependencies. And then finally, we copy it all to some distribution folder, and we can push it to the cloud. That's the mental process we're trying to think about, is how do we take the things we do locally, npm install, Angular build, copy it all to a distribution folder, and then push it up to a server. How do we do that? And then do we have to think about, I'm running Windows 10, you're running Mac OS, it's running Ubuntu on in the cloud, or maybe it's running Linux. Maybe the CI server, if you got that, it's running a different OS. Or maybe you are all using the same OS, but are you using the same version of Node? Did you know that some NPM packages will work differently based on different versions of Node? Just like with NuGet and .NET, there are certain versions you have to synchronize. Are you 100% confident that when you deploy to the cloud server, the thing that worked on your machine is going to work there? I'm not usually, but I'd like to be. So that's the thing we want to keep in mind here. And the thing that kind of helps us solve this is Docker. Docker solves that problem. This is when I got to the point where I was like, OK, the place I was working, we had hundreds and hundreds, almost 1,000 apps. And I couldn't constantly be debugging. Why does it work on this person's machine but not on the cloud? What's going on? Docker solves this. If it works in Docker, it'll work on any of your machines. I'm like, OK, that sounds like great candy. Let me have a bite. To do that, though, we have to understand how Docker works. So what's this mystical Docker thing? Well, they've got this thing called a Docker file. And the Docker file, once I realized what it was, I was like, oh, I already do this. Do you already know the steps it takes to install NPM in your project and get it running locally? Yeah, because you're working on it every day. The Docker file is actually just a recipe that you write down that is those steps. It's a self-contained script that's a recipe for creating and running our application. And then once we get that script running, we can configure it for different environments. So we might have a Docker file that looks something like this, where we say, OK, we're going to run on Node 8.9. We're going to set our environment variables. We can have as many as we like. We're going to set our working directory up, copy over our package JSON, run npm install, copy the folders, expose whatever port we want, and run npm start. This is probably what you tell your neighbors at work in the cubicle next to you. You're like, OK, go run my app. Will you try this out for me? Here's the steps. And you send them an email or a Slack message or whatever. The Docker file is that thing that we're writing down as our recipe, so we can do the same thing. But if you're anything like me, you were like, sigh, I got to write all this stuff down now, and I got to remember it, and now I got a new syntax. And most of my Docker files aren't 8 lines of code. They're usually much more involved. Thank you so much. I'm full of tech issues today. So what can we do with tooling to help solve this problem? Guess what VS Code does for you? Adds Docker files to your workspace. You just hit a button, command palette, open it up. Thank you. Thank you very much. Open the command palette up, hit add Docker files to the workspace. And you can get that from the Docker extension from this link. And then once you add that, you can then edit your Docker file. Well, what if you don't like the Docker file that it comes with and you want to do something different? You can change it. If you want one that's specific for Angular, if you pull down my extension for Angular Essentials, there's actually a Docker file snippet that I have, which you can see here. I type in Docker, multi-stage. It pops in a bunch of different things that you can do. It's a multi-stage Docker file. The top one is building the Angular application, running that ng build on line 8 for production. And then lines 10 through 15 build the Node server. That's my recipe for the Node server. In both of those, I'm saving the Angular app and the Node app out to a variable, effectively, on lines 2 and 11, called client app and Node server. Those are like, think of like temporary containers for Docker. And then finally, in the final image, I say, go grab the stuff from the Angular app, grab the stuff from the Express app, put them into the container, expose the port, and run them. Now I have something that's running for production for my app without all of my source code. It's just the built files. So VS Code can help us generate all this, so I never have to type anything anymore, which to me is fantastic. So we create our Docker file, we build and run it, and then we could debug it. If you're like me, you're probably thinking, you know, one of the hangups I have with Docker, John, is that I want to make sure that what runs on my machine is exactly what was running without Docker as well. Like when I run locally, I can see my code. I can explore my files. I can debug it. I can look at the logs as it's running. When I go into Docker, I keep hearing the words container and hiding them in images. Can I still do those same things in a Docker container? The answer is yes, but let's prove it. So here in my application, I'm going to run my project locally. I have a command called npm run local. which will run it here. Or maybe it won't. Let's kill that. Go back in. Do npm run script. And locals down there using the npm extension. There we go. And there's my app. It's amazing. You can see all my friends. The heroes are Vikings. And who are the villains today? There we go. Let's stick Chris Diaz in here since he's in the room. You're going to be a hacker of Node today, Chris. So we've got an Angular app. It's running locally. Everything's good. And if I want, I can debug this application. So how would I do that? Well, locally, I've got another npm script called debug. So in here, I can use VS Code to go debug that. We can still browse to it. It's on the same port. And then when I go inside my code, I can go into, I think I have a file called service.js for heroes. I've got a breakpoint right there on get heroes. Did I start the debugger? No, that often helps. And then up here, I've got a script called launch via npm. So let's go kill the process, and we'll launch it from scratch just to prove it works. And when I click on this little gear, you can see launch from npm just runs my debug script. The debugger is now up here at the top. You see this little funky thing I'm dragging around? That's my little debugger. We'll go back into my service. We'll see the app. I'll refresh my heroes, and bam, I'm debugging locally. This is something VS Code just does out of the box for us, and I can do everything I need. But when I go to Docker, can I do those same things? That's the real question. Well, first, let's see if we've got our Docker files. There's that Docker file we looked at earlier that I showed up on the screen. If you wanted to get these, by the way, you just do Command-Shift-P, and you type in Docker, add files to Workspace. You choose your preferred language, like Node.js. You choose the port that you want. And then it's going to warn me, you already have these files. You want to override them? Let's do it real quick, just to see what happens. And then you can see this is the Docker file you get out of the box. You also get a Docker ignore file right up there. And you get a Docker compose and a Docker compose debug. We'll explore what those mean in a moment. For now, we're going to undo the changes. Thank you for Git support in VS Code. All right, so how do I run the Docker command? I've yet to run a CLI command, right? Which is kind of how Docker came out. If I do Command-Shift-P, and I type in Docker compose up, we're going to run the Docker compose file I just created. Before we run this, let's go look and see what that does. There's a compose, and then there's a compose debug. So Docker compose allows me to run multiple Docker files if I want to. In this case, I just have one. It's called Vikings. I'm saying build dot. It means build everything. The environment's going to be production, and the port I'm opening is 3001. Docker debug, Docker compose debug, overrides some of the settings, saying, you know what? I'm going to run it locally, so use this .env file to set my environment variables locally. I don't want to manually have to type in all my environment variables, like my database keys and stuff. And I don't check those into GitHub for obvious reasons. And then I want to expose not only the real port, but the debugging port, and I want to run it with the debugger inspector as well. So the Docker compose debug is for running locally for me. And it's going to run that Docker file. So now I can go back up to my command palette, type in Docker compose up. It's going to ask you, which one do you want to run? We'll run debug. And down below, you can see the commands running. Now, if you haven't used Docker before, one of the cool things about this, drag it up a little, is you can see right there, it's showing you the command it's going to run. So it's running a Docker compose with the file flag to say, use that file, do up with -d and -- build. And do you have to know what those mean? No. Could you have typed that yourself? Absolutely. But it's doing all this work for you, and now it's going through the steps. Notice it's going step 1 through, I think, 7 or 8. It's doing my production Angular build. It's going to uglify all that, do that tree shaking, the AOT, everything I needed for my application. And once I get past this step, it's actually pretty quick. There's my chunks. We can scroll back up and see how big my project is and all the files that are there. You can see the cache busting in play. Those are the weird file names. Then it moved on past the intermediate container. The intermediate container is the Angular app. And now it says, OK, go to my Node server. It's running npm install for that. It then created an intermediate container for that. And finally, it successfully built my container. Yay! So I got a container, right? What do I do with it? Good question. I call Chris Diaz because he taught me Docker. I have a Docker extension in VS Code. This is the link I showed earlier in the slides. The Docker extension enables those features I just showed you. Now, I should be able to see an image in here. And the first image on that list is my Vikings latest, created a few seconds ago. So that's an image. An image is basically a blueprint or a template for your code. With that image, I can run in multiple containers if I want to. So think about scaling up long term. Right now, I just need one. But with that image, I can go run that image in a container. Luckily, when I ran Docker Compose, it automatically did that. It created the image, and it ran my Vikings container. Now, before we go look at that, let's make sure we're not running any more Node code locally. Like we have a couple terminals open. If we are, let's close them, make sure nothing else is running. Good, nothing was running. There's Docker Compose. We can even kill that. If we go out to 3001 now, oops, there's our 3001, because that's the same port we're running at. And we refresh. This is the container running my application. Now, if I want to debug this, what could I do? I could go to the debugger, and I click on the little gear there, and let's go look what's in there. There's a launch configuration called Docker attached to Node. I'm saying, OK, I want this debugging to attach to the running instance of that Docker container. I'm going to open up that port, use that. Same port that I exposed through Docker Compose. Then it's running on localhost, and I have to map the source code. So when it's running, I want to be able to map the source code in that container to what's on my machine. And I happen to know that the remote root, which is in my container, is user source app, because I created it with my Docker file. And the local root is using a replacement variable to say, go to the Workspace folder. And the protocol I'm using is the inspector. So then I select the right debugger. By the way, common mistake I make is I just go and press the button. Always make sure the right debugging profile is selected. So I'm going to go press that. Once it's selected, you can do F5. Now my debugger is running. We should be able to open up that same file we looked at a minute ago with the breakpoint there. And now, if I refresh, my breakpoint's hitting the Docker container. So we've just proved I can debug locally without Docker or with Docker with effectively no additional effort to do the debugger, just a different debugging configuration. So how do you get that debugging configuration? This little blue button down here in the corner. It's very, very powerful. You pull that up, and you can choose a variety of different ways you can debug Node. We did Docker attached to Node for that last one, and that will generate that launch configuration for you. And the only thing you're likely to have to change is if you made your path in the Docker container different than what it provides, which makes sense. It's wherever you put your code. All right, we didn't prove everything, though, with Docker. The other thing I like to know when I'm looking at my code is, what if it didn't work? One of the more common debugging techniques I know with Docker is sometimes you deploy your code, and the file structure that you think it has is not the file structure that you sent up there. Have you ever deployed something and you thought it was all in a www folder, but then when you actually looked at it, you actually just put the contents of that folder up there and forgot the www? Sometimes pathing is the hardest thing in programming. So it's kind of nice to be able to see what is it actually doing. So if we come up to our container, we can right-click, and we get a bunch of options. We can show the log, start and stop the container, attach the shell. Let's try attaching a shell to it, like a turtle. Now I've got a shell into my container, which you could memorize this, by the way, if you like. That's the command it runs. And now I can run things like ls. What's in my container? And I happen to know that I've got something called server.js. I can run cat server.js, which will let me see the contents of that file. I know that I've got a file in my project called index.js server. Like, this is the file locally. Let's see, and this should be in a folder called server. Let's go see if I can find that down here. So I should be able to say, OK, first, is there a server folder? Yes, there is, right there. I can then go cd into the server if I want, do an ls. There's my index. I can do cat index.js. There's the same code. So what you're seeing locally is also in the container. What about showing the logs? Like, sometimes you have an error and you want a log. You can right-click on the container and choose show logs. When you do that, now you're seeing I'm running Mongoose with MongoDB in the background, and you're going to see all the messages that are happening. So if I come down here, and we clear out those messages, and then we come up to, I didn't clear them out. Clear. There we go. And we come up here and hit refresh. Now you'll notice there's a new message there for the read that I just did. This is super powerful for debugging because now you have full access to the container on your machine. Now this is a talk about Azure, right? But I have yet to talk about how Azure works with this. And again, the reason for this is before you go to the cloud, there's a lot of things you got to really make sure are working. Your app works locally, great. Can you debug it locally? Great. If we're going to use Docker to move it to the cloud, so we don't have to worry about versions of Node and operating systems and incompatibilities, we want to make sure Docker works locally and we can debug it. And with VS Code, we just add the files to the project, run it, turn on the debugger, and we're good. Switch back over. All right, so we took a look at how we can use Docker to do all of that. And just in hindsight, that's where you get the extension from. The next step is you can then take that image and push it to Azure. To do that, we can look at the image, and we can do different things to it. We can tag the image to tell it where to go. A tag is effectively just another name for the container, for the image. In this case, I'm tagging the Vikings image to be telling it, go put this image in Azure in a place that I can then deploy it to the cloud. Why do I have to do that? It's called a registry, a container registry. When you use .NET, you use NuGet to put your packages there. When you use Node, you use NPM to put your packages there. With Java, we have Maven. With Docker, there's Docker registries, container registries. There's Docker Hub, which is a public one. Azure Container Registry is one that Azure provides, and we can push ours to an Azure Container Registry, so then we can deploy that image to any Azure app service that we want. So from there, we can take it right to the cloud. So the idea here is we're going to compose our app. We're going to tag it, give it a name so it knows where to go. We're then going to push it up to that container registry. Once it's in the container registry, we should be able to see the web app in the cloud. Let's see if John is full of it. One thing I love about working with Azure for a living is you rely entirely on the success of your demos based upon the internet connectivity that you have at that moment. So we're going to see how this all goes. First, I'm going to turn off my local container. We'll stop the container, just nothing's there. In fact, let's just remove the local container. It should disappear in a moment. Yay! Then we're going to go to this thing called the internet. And on the internet, we're going to go see a running version of my site. You can all hit this if you like. Be nice if you do. There's the URL, Papa Vikings rule. That's what's up there, and it's saying hello to you all. How kind of Azure to do that. So now, let's say we want to make a change to the app, like the welcome to build. So in the application, let's scroll back out. There's a page in here called Toolbar, and you'll notice here is where I have my name of the site. So in there, I'm saying welcome to build, and we're going to say, please work, oh, internet gods. Like that. Now, if I run that locally, you're going to see that change. The change we're looking for is to change the message right there in the red. So I've just made that local change. Now what I could do is I could go ahead and run Docker Compose up, this time selecting the real Docker Compose, not the debug one. Now, why did I do that? As it's building, let's go take a look and see what's happening. Inside of my files, I had a Docker Compose file. And notice I'm kind of struggling to find where that file is. Let me teach you a tip. Command P, type compose, hit enter. It finds the file for me. No more looking through tree views. So up top, this is what Docker Compose is doing. Notice there's no more debugging involved. It set an environment variable called production and opened my port. But I'm using a database. You don't see any database keys there, right? Notice I have this file over here called .env. This has been git ignored. This is where all my magical keys are. This file has my database keys and any other authentication and stuff that I might have. Give you an example of what one looks like. Is in there, I've got my environment variables. And there's an NPM package which allows me to look at this and basically set them for me. When I run locally, I need that in my local machine. When I run in Azure, I go set my environment variables separately. We'll show you how to do that. So this Docker container I just created, which it did down below, if we go look inside the Docker extension, you can see it was created a few seconds ago, and it's running right here. Let's go show the logs, and let's try to browse to it locally. Where's my data? It doesn't have access to that key, right? I did not put the environment variable flags, the file, in that container, because for security reasons, I don't want to do that. But I still need those to run. So locally, the Docker Compose is not running for me, although the one in the cloud is still happy, it's still welcome to build. So if I come back over here now, and we look at our image, we want to make sure we can get that one up to the cloud first. So let's get our changes up there, and as it's doing that, we'll explore the environment variables. First, I need to tag this thing. If I right-click it and I say Tag Image, you'll notice up top, it's prompting me, and it says, hey, would you like to call this Papa CR, Azure CR to IO, John Papa, Vikings latest? It knows where to send this because I have a setting in my VS Code settings that says most of the time I deploy to the same registry. So that's a setting in the settings file. And I'm going to tell it, yes, tag it like that. And then once I do that, if I go back over to the left, you'll notice I now have two things created 2 minutes ago. It's the same thing with two different tags. So how did it know that name again? Let's go look real quick. If I look at my Azure settings, you can see right, where is it? There it is, line 13. My default registry, that's where I'm sending it. If you don't have those, you'll have to just type it in. But I like to set it there because it's more efficient. OK, so now that I've said tag it, I can right-click it again, and now I can push it. When I say push, it's going to try to go up to the Azure Container Registry. And I have not yet authenticated to go there. So now I'm going to use a command from the Azure CLI, which is ACR login name. It's in my README file for this. And you'll have access to this entire repo that you can run all these same commands. I'm going to type that command down there. And then the name of my registry is Papa CR. And I'll type that. And it should log in. Hopefully the internet's working for me here. Hey, I succeeded. Great. So now let's go ahead and push again. We'll do push. We'll watch the messages down below. Notice these different layers already there. Several of the layers say they already exist. When Docker containers get created, it has different layers in there, and it separates out things that don't change. Effectively, it says a lot of this app didn't change. The only thing that changed was that one title. And that's what it's pushing. It pushes my differences. OK, so it pushed it up to Azure. Once it pushes it up to Azure, it then goes into this thing called the Azure Container Registry. If we come over to, is that it? I get the logos wrong all the time. Let's try that one. That's a resource group. I go to the green thing a lot. That's everything. Papa, CR. Bam. All right, container registries are like a dark cloud and a happy cloud. Got to remember that. If I click on repositories, I'll make this a little bigger. You can see I have a repository here called Papa Vikings. If I click on that one, you'll see their tag there was latest. If I click on that, you'll see what's inside of that. Scroll back over. I can also create a webhook. A webhook says, every time I get a new version of this same container with this tag, go ahead and run this webhook and do something. The webhook we can set up here is to deploy it to the app service. Now, I believe I already have the webhook set up. So let's go look down here at webhooks in the Azure Container Registry. There's my Papa Vikings rule. I can click on that. Over here, you can see that on May 9th at 1:40 p.m., there was a push. That webhook got invoked. So if we go back up to our site, and this is right here, and it said welcome to build. If I refresh, I spelled please wrong, but it worked. Azure does not have spell check, but it works. Pretty good. And usually this takes anywhere between 7 to 10 seconds for me when I do the full demo to get it up there so you can make the change and go through that. The longest part is rebuilding your Docker container, which you saw in this case with that minor change. without logging in, it's about 30 seconds. It wasn't that bad. Depending upon the size of the change you make, there's more that you can do. Very cool. All right. So the key points here that we looked at is we get a great debugging experience with these different experiences. These Azure Node extensions, which I've got another one to show you as well, help us do a lot of the things so we don't have to remember all those commands. Then we get this great Docker experience with these extensions. Basically, VS Code is making our lives a lot easier. But remember, I said that I had these environment variables as well. How do I actually set those? Well, there's this extension called app service. And let's get rid of those files. There we go. In the app service, we can see our build Vikings application settings. I'm going to move this over because my security key's in there. This is where I can set the environment variable flags. There's my key. You've got the first 12 characters. So that's my database, my key, my port. All the things that my app needs to run are set right there. Not only is this read-only, but you can change it. So I can right-click, I can add a new setting. I can also say, you know what, it's not Vikings anymore, I can edit it. And I can change that to another name if I want to. You can add new keys, you can delete keys, you can rename the keys. Makes life a lot easier. Once you've got that up and running, you can have your access to your database. Now, the app service will let you do other things too. If you're not into Docker, other options you can have is go back to your code, and if you right-click somewhere inside your folder structure, let's say I'm right here, I could go and say, all right, I want to deploy my app. If I get out of this, I'm actually one folder too deep. You can actually right-click and say deploy to a web app, so you can push your files up to the server directly. And then the other thing that's nice is, let's say I want to see what's in my database. This Cosmos DB extension is actually more than Cosmos. I can actually look at my local database running Mongo locally, right here with attached database accounts, and I can see what's in there. Or I can go up to my Vikings database in Azure, I can connect to it, I can then see all the villains and heroes I have, open my collection, and these are all the heroes that you saw up in the cloud. You can see down there, somebody's adding Bill Bixby, and you're all having fun, Papa John's, ha ha ha. I've never heard that one before. And then throughout here, you can create your documents, collections, etc. One of the things I love to do throughout this is you can create a scrapbook by clicking this little button right there. And in the scrapbook, you get IntelliSense. Say db.heroes.find. And then I can hit Command, Shift, and quote, and it's going to run that command right here. So it's all very interactive. And I can do other commands in here too, like db heroes dot delete many. No, don't run that. So you can run all this stuff right here inside the tool. It runs against Cosmos, or if you're like me, a lot of times you want to run locally first in a local Mongo database. You can attach your local Mongo, and I can say, okay, let's right-click, connect to it, and after I'm connected, I can then go over here, and I can run this, and you'll notice the names over here are slightly different now. There's John and Dan and Dustin. So you can access different databases using these scrapbooks. And the scrapbooks are actual files that get put into your project that you can save. And I do this a lot, because a lot of times I'll be testing out the data, and I'll save those scrapbooks in GitHub. I won't deploy them, but I'll save them as development resources so my team can share them for local testing. So hopefully you got a good sense of seeing all these. There's other Azure Node extensions that are really awesome, and there's a couple of great sessions that you can check out to see these. With those tools, you can build all this great stuff. And if you look here at these resources again, I promise I'd show it again. These are the different extensions that I showed today that allow you to do everything that we did here. You'll also be able to get access to the GitHub repo that's up there. If you go to github.com/johnpapa, you'll find the Vikings database right there. So just go find John Papa on GitHub, and there's a Vikings application there that you can play with. These are all the extensions and the shortcuts that we used. And there's some wonderful other sessions that you can check out. What I didn't show was also Azure Functions. There's a great session by Simona Coden and by the Azure Function teams where they show how to do these. There's a session by Matt Hernandez on this list as well where it shows you how to use other extensions that we have. We've got a storage extension, a SQL Server extension, some really good stuff coming into VS Code now. It's really making Node light up. And you know what? When you got great tools, it makes it a lot of fun to code, and you're much more productive. I want to thank you all for coming, and I hope you enjoyed it. If you have questions, please feel free to stick around.